Hi there, and welcome to this video series about Salesforce functions. This first video is going to be an introduction. I wanted to cover many additional topics, but the video would be way too long. In this video, we're going to cover creating a Salesforce function. We'll take a look at what's inside. I want to look at the Java specifics and improve on the Java template. We'll see how we can run the function and test it, and then deploy it to Salesforce. In future videos, I want to look at some more advanced use cases. We're also going to look at different testing frameworks we can use. We're going to do some benchmarking. I also want to do a bit of a deep dive into the Docker container and the Java process itself. We'll look at using alternate JVM languages such as Groovy, Scala, or Kotlin. And I want to see if I can get it to work with Gradle. But for now, I just want to create a function and get it up and running. So let's get started. So I'm going to go ahead and create a function. Now, first we need to create an SFDX project. If I try to create a function without being in a project, it will give me an error. So first I'm just going to create an empty project here. And we'll use the empty template for that. And I'm going to call it function demo. Function demo. Now once I'm here, I can create my function. So for functions, we actually need to use the sf command rather than sfdx. So actually sf comes with sfdx, and here you have the generate topic, and I won't go through the whole thing, but if we do sf generate function, and I always like to look at the help options. So here it does take some flags. We have a flag for language and a flag for function name. So I actually want to do this in Java, as that's going to be the main focus of this video. And the name, we'll just call it example function. So that's now created the example function for me. And it's also telling me now I need to enable functions in my DevHub org and also add the functions feature to my Scratch org definition file. So we're not going to do that just yet, but we will get back to it shortly. So I've got this project now imported into my IDE. Now I could just import the function. In this case, I've chosen to import the entire project with all the SFDX stuff. But you could also just import this function as a Maven project, because actually it's a pretty standard looking Maven project. We've got a POM file, and we've got our usual source, main, and test directories, which have Java classes for the main source and the test as well. If we take a look at the POM file, it's a pretty standard looking POM. It's got some properties here. It's running Java 1.8, which we can actually upgrade. And then here we have all of our dependencies and some build plugins. So actually we can come back to this a bit later. There's a lot of cleanup we can do. Really all you need to make this run is the SLF4J logging API. And of course we need the Salesforce functions SDK. Let's take a look now at the structure of this project. So if I go through the source, the main class is this function class that got generated, which is called example function. So I'm actually going to just go ahead and rename that because it's not very nice to read through that function. So we'll just call it example function and do the refactor. The function class is implementing the Salesforce function interface. So any function needs to implement this interface, and there can only be one class implementing it per function project. We can then have multiple function projects if we want to have different functions. But if we try to put two classes implementing this interface in the same project, the function will actually fail to start up. Let's now take a look at this interface. So this is a pretty standard functional interface. It has two parameterized types. The signature is apply, which takes an invocation event of type T and a context, and it returns a return type of type R. If we go back to our concrete implementation example function, here we're using that interface and we've given it types function input and function output. Let's take a quick look at that. So function input is actually empty, but we'll do some examples later where we might actually add some data into here, but in this example it's empty. And the output is just a list of accounts, and the account is just a simple Java bean with an ID and a name. Looking back at our function now, we can see what this is doing, so it's not really doing anything special. It doesn't take any input, and the output is a list of accounts, so it's actually going to run this SOQL query, which is kind of cool. We can run queries directly against the org. And then it's just going to build a list of all the accounts that we got from this query, and that's it. So we'll try to do something a little bit more useful later. For now, I just want to get this running, and then we can look at some more interesting use cases. Before running it, like any good project, we want to run the test classes, and as expected, there is a test class generated, so we can take a look at that. And it's a test class, it's doing some mocking, so this is a test that probably knows a little bit too much about the implementation since it's mocking this exact query, and they're going to return 2 records. But it is just a standard Maven project, so we can actually just run this test from the IDE. And yeah, so I went ahead and ran my test. There is an error here about, or warning rather, about the logging framework failing to bind, so we can definitely fix that. But for now, that's not so important. It does run, and now we can try to run it as a function. Before running this, I do want to make sure it builds using just the regular Maven goals rather than building it in my IDE. So I can do that by running Maven compile, and I can also run the test goal. Now, in case you don't have Maven already installed in your system, you can use the Maven wrapper here, this mvnw. So I could just run mvnw like that, and I can do the same thing, and that'll work just fine. To run this thing, we need to again use the sf command, and it's going to be sf run function, and we actually want to use start. And you like to always see what kind of options are available. So actually I could just run it like that and it should go. We have debugger ports, language port, and verbose, so these all have default values. We can run it as a container or locally. If we read through the description here, we'll see that it runs locally by default. Otherwise, we can explicitly tell it to run locally or as a container. So for now, we're just going to run it locally. So as it's building, we can see that the Maven compile target runs, but not the test. So if we want to run the test, we do need to run that manually. We can see now that we have some kind of server up and running. It doesn't say the port, but it's port 8080, as we saw back in the default values here. We'll be running on port 8080. It does output here a debugger port, 9229, so that's actually used for debugging, and we'll do a little test of that later. So in order to call my function, I've opened up a new terminal window. We can't actually call this from Salesforce or from anywhere else. We can test it locally using the sf command again. So if I go to sf run function, and again I like to look at the options, we can see here you've got headers, which we're not going to use yet, but the function URL is going to be important, connected org, payload, and structured. So we're mainly going to use these 3. These are kind of required. So let's give that a run, and you actually have an example here. So we'll try something like that. Before running this, we need to make sure we have an authorized org. So in my case, I have tons of them, but you can check this by running sfdx auth list, and I'm going to use one called, which I believe I gave an alias of func, so I'm going to just filter that. But you don't need to add that extra grep part, that's just to filter it out. So yeah, I have this func one here, which I'm going to use to see what accounts are in the org, because that function is actually just going to query the accounts in the org. So now let's go ahead and run this function. So I'm going to give the URL, which is going to be localhost 8080. And I'm going to give an org, which is going to be this func org that I have here authorized. And I have to give it a payload, which needs to be a JSON input, which could be a file, or I could just put something into the terminal here. If you recall, this function doesn't actually take any input, but I do require it to pass a payload, otherwise the function won't even run. So let's do that. Okay, now I'm running into a connection refused error, and this actually happens to do with my Node.js version, and I won't get into the big details on that, but basically it's trying to use an IPv6 address. So instead of localhost, I'm going to just use the loopback address 127.0.0.1, and that should work instead. And yeah, okay, so that worked. So now that's contacted my org func and gotten the one account that's in there. So there's my first call to the function, which is pretty cool. Even though we're running it locally, it actually did go connect to an org and get the account data out of that org. So that's pretty cool. After running the function, I can go back to the server output here, the function output rather, and I can see the log message. So if you recall from the code, I'll go back to that in a second, but we did have a log statement. So here there's a log which says function successfully queried one account record. And back to our code, we can see that logging statement here. So that's what we saw out in the console in the terminal. We can see it here. Now what I want to do is connect to a debugger. Since this is a Java process, we can actually go ahead and debug this, which is also kind of cool. Let's edit our configurations here. And I want to add a remote JVM debug. We can call this function demo. And remember the port was 9229, so we need to put 9229 in here. And now we should be able to connect to this remote Java process. And it worked, so we are connected here. And let's go ahead and set a breakpoint, and we can just run through this code. So if I run that again, it should stop in my debugger. And there we are. So the code stopped here, and I can go ahead and inspect all the variables and do whatever normal activity you would do in the debugger. We can step through code. So I won't step through this whole loop. Well, actually, there's only one record, so that's pretty quick. But yeah, we can debug, so that's pretty cool. You can't really do that with Apex, so it's kind of nice to be able to do live debugging. To make this a little bit more interesting, I thought we might see what happens when an error occurs. So there actually is an error in this code here, and we can definitely reproduce that. So I'm going to go ahead and do that. I'm going to skip the breakpoints here so we don't actually stop in the debugger. I'm going to just show what the error is, and then we can use the debugger to fix that. So recall we passed in this org property, and if you'd had a default username set, you don't need that, but I actually don't have the default username set. We can actually take a look at that. If you do a sfdx config list, here in my case I only have a default devhub username. I don't have a default username set. So if I run this command now without the org, this should cause an error. And yeah, so this gave me a nasty 500 internal server error. And I mean, I know what the issue is, obviously, because I didn't pass the org, but from a coding point of view, we can probably handle this better. As an exercise, we can use the debugger to find a solution for that. So here I am stopped in my debugger. I've got my breakpoint set, and I can now actually inspect this variable. I can either do it down here, or I like to use the evaluate mode directly. And we can actually take a look at what's in this context. And I noticed if I do an org.getID, we get this long string of zeros, which is probably 18 zeros, which is a Salesforce ID, but it's not a valid org ID. So ideally, what we want to do in this code is compare this value, and if we get this value, we can send an error message rather than trying to continue. If we continued on to get this data API in query, it's going to fail. So we can check this value, and let's build the condition right here. So these are some things we can do in the debugger that you can't really do so easily in Apex. We can check this condition right here. So we have our condition, and we can, let's go ahead and throw that right into the code here. And we can clean this up a bit after, but for now I just want to get it working. If I get into this condition, we can log a message. So we can say something like no org found. And we're not just going to continue because that will fail. What we can do here is return an empty list. So I can return a new function output, which takes a list of accounts. And we're just going to give it an empty list here. And that should do. That should better handle this error. So I'm going to compile this, and we'll see if I'm lucky it will hot swap for me. If not, we'll just restart the process. Yeah, so let's try to hot swap that. And that seemed to work. And let's see, well, I will run that out, and probably still failed here on the terminal. But let's try it again, and we'll see if it actually did manage to hot swap my code. And it did, actually. So I didn't get the error. And if I look here, I should see some logging output, and there's my message, no org found. So that worked, and I was even able to hot swap the class. So that's pretty cool. I wanted to take this a little bit further. So I've now added an error message variable here to the function output, so we can actually send some message back. Because if you recall, in the previous demo, when there was an error, it just gave back an empty list. So it didn't actually signal an error, but rather just gave an empty list. So here I've added the error message variable. And I've gone ahead and refactored this a bit. I didn't want to do that live in the video, as it might have taken too long, but I've extracted these as variables. I've checked here, this is the same, but I've added another condition. I'm checking that the org is actually even present, and actually looking at this should be the other way around, because we want to check if the org is present first, and then we want to check the org ID. So that's even better. Here nothing's changed, and I've cleaned this up a bit. Rather than do a loop, I use some lambdas to map this, so you can argue of whether or not this is clear, but I find it much clearer. And then we return the account list. Now, after making any change like this, it's always a good practice to run our unit tests. So I'm going to go back over here and run our function test. And the test still passed. So don't worry about this hot swapping message. That's unrelated. That's just because my debugger was still connected, but the test still passed, so that's a good step. Now we can go even further and test additional cases, because here we're only testing the case where the org exists. But that new functionality we just added, actually, what happens if our org doesn't exist? So we actually could write some test cases to go into this code. So let's go ahead and do that. So first, I'm just going to rename this test function, which is called test. I'm going to call it test get accounts, since it's getting all the accounts. Now let's create another test, and we'll call this no org supplied. We can take our function here, and we need to create a mock context. Now, I'm not going to use the entire mock context method, because actually I don't need everything that's in here. I just need the org, and I need it to not be present. So actually, to do that, we will just use this when, and we'll say our mock context, mock context dot get org. Then we just want to return an optional empty. Now we can call the function. Here we'll use the same mock event, and we'll use our mock context. And this should return some kind of function output, call it output. And now we can do some checks on that. We can do, we can do an assert true. We'll say output not equal null. We can do some other checks. So what we really want to check is we want to see that there's an error message. So this should not be empty, actually. And we want to check accounts should be empty. So that should be good enough. And my goal here is not to make the perfect test. I mean, we can make these tests even nicer, and I'll probably do another video on that a bit later. This is just to get an idea of how we could improve this. So let's go ahead and run it and see if this test passes. And it does. And finally, we can run this again from the terminal with that change. And this time we should get an error message rather than just an empty list. And there it is. And one thing I do want to fix here is this logging error message we keep seeing. So the issue here is that we're using SLF for J. So SLF for J is a simple logging facade for Java applications. And when we run this in a container, the container will provide an actual logger, a concrete implementation, although we don't have one. If we look at our POM file here, we just have the SLF for J library, the API. What we need to do is add a concrete implementation. So I'm going to do that. I'm just going to use logback. So I happen to already have this ready to go. You could use other logging providers, although I'm going to use logback. Notice I'm adding here just the test scope. That's because I don't want to actually deliver this to the runtime, but for my tests I want to make sure it's there. So just by adding that, I should get log messages here, and let's see what happens if I run this. So now I get log messages when I run my tests. So it's definitely a much better practice, and let's try running all the tests here. So here I've got my 2 account records queried, and here I've got my no org specified. So there, my logging is now working. Up until now, we've just been running the function locally, and we did a few tests in the IDE, but now I want to run the function as a container. So if you recall, when I start the function, I had 2 options to run it locally or as a container, and now we're going to run it as a container. Now this actually requires Docker, so you need to have Docker installed and running if you want this to work. And here we go. So now Docker is getting up and running. If you're not familiar with containers, basically a container is a way to package your software and ship it in a standard way. When I run the function locally, it's just using whatever I have configured locally on my system. So it's going to use my Maven, my Java, and whatever else it finds on here. When I start it as a container, then it's using whatever is specified in the package, and that's going to be exactly the same as what's running in production. Okay, so now that function is up and running, and it'll seem very much like running locally, except it's actually running in a container. So it's running in a virtual machine, and this is exactly how it will be running when it's actually been deployed to Salesforce. So for our purposes, it's the same. We can still call it the same way we did before on port 8080. And we can see the same logging messages. And the same debugger port 9229 is still there, so we can connect to that. And that works. And we can see some JVM options here. For example, the 300 megabyte heap size, so keep that in mind, and we'll see maybe we can play around with that. And for those who are familiar with Docker, when the Docker image is running, we can actually query the Docker process. And we can see here our example function is running in a Docker image. And if we wanted to, we could go into that container. We could log into it and see what's going on in there. I'm not going to do that here, as that would probably require a whole other video, but it could be a fun exercise to do someday. Now, there is one last thing I want to fix before we actually go deploy this as a function. Recall that we're working with Java 1.8, and I actually might want to use some libraries that require a higher version of Java, and 1.8 is kind of old. For example, I was doing some testing with this caching library, which we might do some tests with later. But let's see what happens if I include this Java 11 library. Just including the library in the Maven build won't be a problem in itself, but if I import a class from that library into here, then we might have some issues. So I'm going to just import a caching class here. I'm not actually using anything, but okay, here we go. So that should cause some issues. Now, if I run it locally, it might work, because actually locally I have a later version of Java running. Let's try that. And locally it builds no problem, and now it's up and running. But let's see what happens if I try to run it as a container with that Java 11 library. So here we have some problems. If we look a bit further up here, we can actually see this message here. Class file has the wrong version. 55 should be 52. So 55, I believe, is Java 11, and 52 is Java 8. So it's expecting a Java 8 class. Now if we scroll a little bit higher up, we can actually see installing Java, JDK 1.8 and JRE 1.8. So that's not going to cut it. So the first thing we'll need to do is update the Java version in our Maven build file. So now it's 1.8, and we want to put something more recent, so we can put Java 11, for example. This alone won't work because that Heroku Buildback is still going to use Java 1.8. We can actually take a look at the Heroku documentation, and I'll put a link to this in the description. If we look at supported Java versions, it actually supports right up to 17. And all we need to do is add a system.properties file with a Java runtime version property of 11, or actually we can even put 17. So let's do that. So we'll update this to 17. And I'm going to create a system.properties file here in the project. And I'll put in here java.runtime.version. And we'll make it 17. Now we can try to run this as a container and see if it loads Java 17 and our Java 11 compatible library. So we can see here JDK 17 and JRE 17 have been installed, so that worked. And now my function started up normally. Now, as a last step, Before we go on to actually deploying this to Salesforce, we are getting there. I did want to clean up this POM file a little bit. So these are regarding the unit test dependencies. We can use some more modern stuff actually. This is JUnit 4, there's JUnit 5, and there are other test frameworks. Although I'll probably do a whole other video just on testing. But for the build management part, I mean, all of this is actually not necessary. We can pretty much just get rid of this because these are all kind of the defaults. And I like to keep my build files clean. So I'm actually just going to get rid of all this and it should work. There will be some other cases where we might need to use specific build plugins, but that's not the case for this simple example. Now we'll just make sure that this works. I'm going to do a good old clean and compile and test for good measure. And it does work. And we'll even start it up as a container to be sure. And that all works fine. Now everything we've been doing is leading up to this point. We actually want to deploy this to Salesforce. So far we've just been running the function locally. We've run it in a local container in Docker, but it's still running locally and not on Salesforce. So if you recall, when we created the function, there was a message in the output saying to enable functions in your org. So what you need to do is go into setup, and under feature settings we have functions, and we need to enable the test space. Now if you go into any old org, you might not have this option available. You might get a message saying to contact your Salesforce representative, so do make sure you have the proper license for this. You can also get a trial org. I'm actually working here on a trial org, so you can sign up for a trial org for functions. And you need to enable, so I've already done it, I can't show it to you again because I've already done it here, but you need to make sure this is enabled. And then we're going to want to create a Scratch org to deploy our function to. So for that, first we need to edit our Scratch definition file, and as the instructions said when we created the function, we need to add the functions feature here, and that should do. And now we can create our Scratch org. So I'm going to stop my local container, and I think I'll need to move up into here, and we can create a Scratch org. It's going to be Scratch, and I don't remember the correct command here, but let's look at the help options. So okay, we want to do config file like that. Let's give it a duration of we'll go for 30 days. Go for the max. I'll give it an alias. We'll call it func demo, and I think that should be it. We need to give it a dev hub, which is going to be func. And let's wait, give it 3 minutes or so. And here we go, Scratch org. Okay, so my Scratch org has now successfully been created. And next we need to create a compute environment. So for that we're going to use the sf command. And it's going to be env create compute. And we can look at the options there, which is always a good idea. So it doesn't have too much, but let's give it an org. So the org is going to be our Scratch org we just created, which has an alias of func demo. And we need to give the compute environment itself an alias. So we can give that, we'll call it func compute. And let's try that. Okay, so that's giving me a 401 error. So actually I need to log into the function environment as well. So we can use sf for that, and we can do login functions. And this should open a web browser. So this will give us a login screen. So we can do that. So this is going to be the username for your DevHub org and password. Hopefully I didn't forget my password. Looks like I did. Try that again. Okay, second time's a charm. And that should have logged me in. Yeah, so now I'm logged into Salesforce Functions. With that, we can now try again to create a compute environment. So I'm going to retry that command. And that was fast. So now that seems to be ready, and we should be able to deploy the function. Now, Salesforce Functions has a specific permission set that we need to deploy as well. So it acts like a user profile, but really it's a permission set called functions. And when the function executes, it will be based on those permissions. So what we really need to do is give access to the account object, since our function is just querying on accounts. But depending what you want to do with your functions later, you might need to give other permissions. So I'm just going to go ahead and create that directly here. So this is going to be permission sets. And we need to create one called functions, permission set, and then don't forget to add the meta XML. And I've copied this right out of the documentation actually, so I'll put a link to that as well. And now we can push that to the org. Which we called func demo. And that should work. Yeah. Sometimes you need to force it. Okay, permissions are deployed. And now we can finally deploy the function, although not so fast, because actually, in order to deploy the function, we need to have a working Git repository. So we don't need to push it to GitHub or anything. It just needs to be a local Git repository. The reason being, behind the scenes, this is actually using Heroku. So if you ever worked with Heroku, when you want to deploy to Heroku, you basically push to a Git repository on Heroku, and that will trigger deployment. So behind the scenes, this is pretty much working the same way. So we need to create a Git repository. So I'm going to just do that really quickly over here. So we'll do a git init, and I want to double check my git ignore file. And yeah, IntelliJ's already added me a bunch of stuff, but I do want to make sure as well that we're not going to commit the idea stuff. That's the IntelliJ files. That should be rather .idea. And there's some Mac OS files that tend to get in the way, and we'll ignore the IML files, as those are not particularly useful to go into Git. And I think with that we should be not too bad. So if I do a git status, yeah, that looks all right. Okay, let's go ahead with that. So we'll add everything here. We'll call this initial commit for Salesforce functions. Yay. Okay, now that we're committed, we should be able to deploy. SF deploy function. And we deploy this to the org, not to the compute environment. The org will take care of that. So it's going to be func demo, I believe I called it. And this should now, oh, did I mean deploy functions? Yes, I did. So that should be deploy functions, not function. And this should now deploy my function. So yeah, actually this output you're seeing is standard Git output. So it's actually pushing to a Git repository on Heroku. Now the output you're seeing here would look very familiar to what we saw when we ran as a container, because it's actually doing the exact same thing, just now it's doing it on a remote server. Okay, so now it's done. Our function is now deployed to Salesforce. Now that we finally got this function deployed to Salesforce, the last step will be to call it from Salesforce, from Apex. So we're going to do this now from an anonymous Apex. And once you can do it in an anonymous Apex, you can then use it in a class. You can use it from a flow or from anywhere within Salesforce. So let's try that. So we're going to use the function namespace function. And first we need to get the function, get a reference to the function. So we'll call that example function. And we can do that by calling the functions.function.get. And this is going to be now the sfdx project, which is function demo, .example function, which is the name of the function. And that should get me a reference to the function. Now I can invoke this function. And like we did from the terminal, we need to send a JSON payload. So here I'm just going to send an empty JSON string. And later on we'll get to some examples with real data. And this would actually be enough to call the function, but I want to get the output from that as well. So I can actually get the invocation, and we'll call that invocation. Here I can actually see the result of that. So I mean, I can probably query that directly, but I'm just going to debug the output. We use the old JSON serialize pretty. It's a good way to see what's going on, and we can run that. And yeah, that seems to work. That called the function, and here's the response with the accounts, and it gave me one account, which is a sample account for entitlements, which I guess is an account created by default in this org. And that's it. So we got functions working on Salesforce. One last thing we might want to do is look at the logs of the function. Now it's running on Salesforce, but we can still get the logs. And to do that, we just need to use the sf command, and we can do sf-env log tail, and we can look at some help options there. And this just takes a target, and I believe we called that func compute, and this should give me the logs of that function. So these are actually logs coming from the Heroku VM that's running. So we can see here a message: function successfully created one account record. It's a little bit hard to read due to the zoom level here, but you know, we can definitely extract this into a file. We can use log drains and external logging platforms to better parse this data. As one quick example, I'm going to just use grep, and I want to get, well, we can grab like info, for example, and this should give me only the info lines. So we get a little bit of a cleaner output there. And I mean, you know, we can play around with that and do more stuff with it. But yeah, that's it for logging. I hope you enjoyed this first part of the series. Let me know what you think in the comments. Be sure to check out the links in the description. I've put all the examples here in a GitHub repository. Stay tuned for the next video, where we'll definitely get into some more interesting use cases, like ones that at least take in some input. And see you in the next video.